Hello, everyone. So today we're going to talk about another topic, which is AI agents. Now, AI agents are going to be phenomenal in 2025 and the upcoming years in the AI industry. Even Microsoft CEO in a recent podcast mentioned SaaS software is going to replace by autonomously AI agents. They will be running large language models or any multi-language models autonomously to complete certain tasks based on whatever the user defines. Now, we have these small agents coming up, and we're going to test them out and demonstrate how to use them. These small agents are created by HuggingFace. Previously, HuggingFace created some other AI agent frameworks, but with their recent launch of the Small Agents AI framework, it's better in terms of performance and implementation convenience. We're only using a few lines of code, and it's very easy with human-readable coding styles. You can create multiple agents working on tasks autonomously. As you can see here, it supports any language models loaded in Transformer versions, including OpenAI, Anthropic, and of course the open source language models on Hugging Face. So, on the GitHub project page for small agents, again, this is an AI agent framework, not a language model or AI model. You'll need to incorporate this with language models to complete certain tasks or automations for your work. There's a quick demo that allows you to try it out. All you need to do is use the command pip install small agents. We're not downloading the GitHub project files directly. Instead, we're using the pip install small agents command, and then we'll start some scripts. There are also examples in the subfolder of this GitHub project that you can try out. One thing that caught my attention is the tool calling agents using LLaMA. I'm going to try this one and modify it a bit to fit my examples and style of using autonomous agents. So, go to the command prompt window to start installing. First, we need to do pip install small agents. Then, it will automatically run all the packages, installations, downloads, etc. Make sure you have Python 3.10 to run this small agents AI framework because that's the requirement. Just follow their instructions. Now, as you can see here, I got some warnings about Python 3.11. There are some issues going on, so I have to fix that. I want to be very transparent about the setup steps here going in depth. Before I modify anything in VS Code, I'll go back here and download this tool calling agents LLaMA Python script. This will be the example script I base my customization on for what I need. In VS Code, I've created a folder and I have my Python example code ready. As you can see here, the LLM models we're going to use are LLaMA. LLaMA is running on my local host machine on my PC, running LLaMA 3. I'll define LLaMA 3 later, but first we have to test if the LLaMA endpoint is working or not. I've tested it, and it's working. Before running small agents, I need to create a Conda environment. I have a script or command prompt ready to create a Conda virtual environment. Once I press enter, it will start installing the packages. I'll press the Y button at the bottom here to confirm the process. It will use Python 3.10, which, as I mentioned, is required to run this AI agent framework. So I've created and activated the Conda environment. As you can see, the prompt in the brackets here isn't base anymore. Instead, we have the small agent's virtual environment enabled in the command prompt window indicated by the brackets. Once we have that, we can start installing the small agents framework again within this virtual environment, and we won't have any problems here. As you can see, while the installations and packages are downloading, there are no red error messages so far. That means everything is smooth. We have Torch 2, 5.1 and CP 3110, which means we're using Python 3.10, and Torch has a compatible version as well. Then we'll download the other SIP packages, and finally, it will extract everything installed in the Conda virtual environment. Back to the GitHub project page. While it's installing, remember to do your pip install small agents. I recommend doing this in a virtual environment using Conda or any other method. Creating a virtual environment works well, and it won't affect your main OS system's Python versioning. Once it's done, you'll see the command prompt move to the next step. Then I'll modify this code based on my needs for working on some tasks, using multiple agents to handle the stuff I need. I'll switch to the other screen to run the results with you guys. Okay, so based on what I need for my AI agents, a simple workflow to create content, I've modified this workflow coding to enable me to use small agents. I've also replicated some code from their documentation, which I've developed further. Visit webpage agent allows me to have access to the internet if I need it. If the AI agents are going to identify some information that I need to crawl on the web, we'll use the DuckDuckGo search tools, which are already included in the framework itself. So, what's included in these web agents, as I've defined here, is something that allows the web agents to use DuckDuckGo search tools. It's an open source, free tool that lets you have back-end coding access to the web and search for information. Basically, that's how we use it. Of course, if you want to use more premium or paid versions, you can use Google Search with their dedicated API keys provided by them. But this way, we can just use the simple DuckDuckGo search and the Visit Web Page tool, which I've defined in the previous sections.
As you can see, I've assigned the models here. I'm using the LLaMA 3.2 vision models in my LLaMA setup. This is from the section where I've defined the use of LLaMA Chat and the LLaMA 3.2 vision models, which are installed on my local hosts. I've pointed the LLaMA endpoint, the base API endpoint, right here, allowing it to access the large language models for the AI agents framework. Once the web agents are defined, you can think of them as individual team members in a workforce. They're dedicated to doing web searches and crawling the web to gather information, which is then put into the context window for the language models. The information is divided into chunks and processed in the next steps. Next, we have the Manage Web Agent. This agent acts like a manager for the web agents, monitoring whether the web agents are getting the right information from the web search inquiries. When we pass the required query to the Manage Web Agent, it will pass some arguments to the web agent, the worker, which will start gathering the information. Lastly, I've defined the Manager Agent, which uses the code agents as part of the whole workforce team. This Manager Agent will assign tasks using tools for coding and web searches. If I need to assign other tasks, I can include them here. As you can see, the tool's equal sign parameter allows me to put those tools within the brackets, similar to what we did with the web agents. However, the code agents mainly focus on managing the web agents. Once they have information from the web, they can pass it to the manager agent, which will then handle coding tasks to generate reports or process the information gathered from the web or content produced by the agents defined earlier. Additionally, we need to import time, NumPy, and pandas as basic requirements for the additional authorization. Then, in my script, I've defined a task where I ask the manager agent to run some inquiries. For example, I'll ask it a simple question. You are an expert in writing movie stories. Help me write a short story for a movie scene with sci-fi, action, and crime elements. The story should be about 20 minutes long. The AI agents will analyze and think about the story's background, details, elements, and characters. This won't generate a full movie script, but it will build the framework or skeleton of the story, including the outline and key scenes. Based on this framework, we can then write more detailed action scenes or acts for the movie. And this is just a simple example of how we can use agents to process information and create content. Of course, you could use just a language model to create movie stories or short stories, but the context size, analysis, and reasoning wouldn't involve the same level of evaluation. It also wouldn't allow multiple agents to work together, like in this example, where one agent gathers web information, another processes it, and another handles additional tasks. In this setup, we already have 3 workers. You can change the inquiry to other tasks too. Instead of creating movie story content, you could ask it to create a program, automate a workflow, or process something autonomously. The number of steps can be defined in the web agents, and it will retry up to 10 times here. For example, it might generate a first draft of content, which could then be evaluated and modified by the Manage Web Agent and Manager Agent. This process might repeat up to 10 times to produce the final answer or information, and that's basically the simple agent example here. And also, all this coding and tasks can be found in the HuggingFace documentation. You can check that out here. I'll link all the descriptions in the video description below. Now let's check out how we can run this after defining the inquiries and everything. First, of course, we have to activate the Conda environment. We go back to the small agents Conda environment. If you forget your Conda environment name, you can use the command conda nvlist, and it will list all the existing Conda environments on your local PC. As you can see, I have several projects going on, and here we have the small agents environment.
To activate it, we use the command conda activate small agents and press enter. You'll see the brackets at the beginning of the command prompt change from base to small agents. That's how you know it's activated correctly. Next, we're going to run the Python code, and it will automatically start working for us. To do that, we type Python followed by the name of the Python file. To make sure I get the name right, I'll just paste the file name here and hit enter. Then, it's ready to go. Okay, so after a minute or two, it generates all the details for me after I press enter. Let's scroll back here and see what happened. It will go through some errors because, of course, we have the manager agent handling the coding. Sometimes the coding might have errors, but it will retry automatically. Let's be transparent about the entire process. As you can see here, when I started calling the Python code and pressed enter, there were some warnings. I tested if the AI agents could access the web by going to Wikipedia, and it was able to access some links, which is good. Then it started running the inquiry using LLaMA chat to process the task. Here, it encountered some errors with regular expressions not matching. That's fine because those regular expressions are meant to extract HTML from web pages. Once it got past that, we started seeing the AI develop the draft of the story outline. The content began to grow longer. It wasn't just one paragraph anymore. As you can see here, another agent, likely the manager agent, is asking the web agents to correct or evaluate something. It marks some context in red, and after evaluation, it improves the content. You can see the agents communicating with each other about the concept of the movie story. I'll zoom in so you can see more clearly what's happening. I'm not sure why there are always some errors, but it happens in my installation and system. Sometimes it gets stuck on errors, possibly caused by the coding agents trying to create code or extract content using regular expressions. It keeps encountering errors, as you can see here with the regular expression patterns in Python. Then it moves to another action and encounters errors with code parsing. But don't worry, it will retry automatically, even if there are errors in gathering and analyzing information. Once it's done, it will repeat the process, adding more content. When the text is green, it means it's creating content for what we need. Then, it creates another chunk of content. Finally, we get the final answer because it reached the maximum step limit, which is 10 steps. The whole process repeats about 10 times here. The output tokens consumed about 2068 tokens, and we generated the final steps. We got the final answer here, and the AI agents replied with a report-like document, creating all the scenes for the AI movie short film. We have the title, the logline about the story's background, and the main characters defined for us. It describes how the characters look and their characteristics, which is essential when creating movies. It also breaks down the timeline for each act within the 20-minute structure. For example, the first act is 4 minutes long and includes specific scenes. Of course, you can highlight this act and use it to work with other AI agents. For example, if I have this tool calling AI agent for LLaMA, I can create another Python script to further refine or expand on this content. Maybe you can duplicate this script, just copy it and paste it into another file. Then, run the specific act, highlight it, and paste the inquiry section where you want it to go into more detail. For example, you could ask it to create detailed action scenes, further breaking down each video act, generating scene descriptions, voiceover scripts, and even what each character is going to say or speak. So, ideally, in theory, that's how you can use AI agents to automate content creation. It's all about automating tasks in an autonomous style. I guess in the coming year or by 2025, the AI industry will be all about AI agents and similar advancements. As you know, I've created a web UI for an AI video generator, which mainly focuses on using Hunyuan Video as the backend, connected through a server-side API. I built this web UI using AI coding agents to handle most of the development. For smaller tasks like creating scenes or drag-and-drop functionality, I did those manually, but most of the work here was done by AI. Now, I'm planning to integrate AI agents into this workflow. For example, in the queue system where tasks are waiting for approval, AI agents will handle generating text to videos or, later, image to videos for Hunyuan Video. I'll implement that as well. The AI agents will autonomously stack up all those queue jobs, generate video clips, and then stitch them together into longer videos in the final section. That's the concept I have for the upcoming Hunyuan Video Web UI open source project. which I'm working on in my spare time. It's how I envision using AI agents effectively. For instance, with the HuggingFace Smolagents framework, you can do something similar without limitations. Even if you need servers to create such things, you can also set this up at home on your consumer PC. So that's it for this video. I'll see you guys in the next one. Have a nice day. See ya.